Hello, everybody, and welcome back. We're looking at question 24, getting very close to the end of our Pascal paper. The smallest of 9 consecutive integers is 2012, the year of the contest. These 9 integers are placed in the circles to the right, so this nice little W shape, possibly for Waterloo, but maybe for witchcraft. We don't know. Placed in the circles to the right. Now, the sum of the 3 integers along each of the 4 lines is the same. If the sum is as small as possible, what is the value of u? So what number do we place in the middle of the W? All right, the actual numbers here don't matter. Okay, the fact that the smallest is 2012 doesn't matter. It's the fact that we have 9 consecutive integers. And here, I'll show you why. I'll show you why. So I did not give myself enough space there. And yet now I feel like my circles are too small. So what we can do is instead we can talk about x and x plus 1 and x plus 3 or something like that. And then later say, oh, x is 2012. But you'll notice that since we're always working with 3 circles in a row, the answer is always going to be 3x plus all these little numbers. And so it's the little numbers that matter. Am I looking at the number that's 1 more than x, or 3 more than x, or 9 more than x? Except there is no number that's 9 more than x. So if we let x be our smallest number, and you're more than welcome to just let x be 2012 if you really want. Okay? But we'd have x plus 1, x plus 2, and so on, all the way up to x plus 8. That would be our 9th number. First, second, third, you'll notice it's 1 less than what you need. Okay? Because of this, because it doesn't actually matter, it's about the relationship, what we can do is really just place these numbers, 0, 1, 2, and 8, and that way we don't have to fumble for our calculator to add things up. We can just sort of add them in our heads. Okay. Now, it's the same sum each time. Okay? So we're looking for a way to arrange these numbers so that we get the same sum each time. Okay? Now, what could we possibly do? Now, important numbers would probably be these here. Well, they called the one u, so we could maybe say st and u. These numbers are going to be important because they're repeated twice. Okay? So we've got, so if you add up all the numbers, you get 0, 1, 2, 3, 4, 8, all the way. So adding up all the numbers would be 36. As I say, I'm dropping the x's. Doesn't really matter. Okay? We'll work out what u is. U will have to look like x plus something, and then we'll add 2012 to that. But the sum of every number possible is 36. But the sum of these rows, it's going to be the same sum each time. Let's call that sum A. So you'll get A here, and A here, and A here, and A here. So 36 will be 4A, right? Wrong. The 36, you're adding up just the individual numbers in the circles. Okay? But when you add up the A's, you're really adding this row, and this row, and this row, and you're counting U. Oops, U should be up at the top, shouldn't it? You're counting U twice, and T twice, and S twice. So 36 plus an extra S, an extra T, and an extra U would make 4A. Okay? So we need to, so the A can change depending on what S, T, and U are. Right? Now we want the smallest possible sum. So we want the smallest A. So we need to pick S, T, and U to make 4A as small as possible, and therefore make A as small as possible. So we'd like to probably pick small values of S, T, and U, right? Now the smallest ones we could pick would be 0, 1, and 2. So 36 plus 0 plus 1 plus 2, right? That would be 39. 39 isn't a multiple of 4. Okay, well, maybe we try something like 0, 1, and 3, because that gets me 40, right? And that gives us a sum of 10. So A would have to be 10 at that point. Okay? So it's all well and good to think that, but how does that tell me what U should be? Right? How do I know what U should be? Well, we have to actually make sure, can I actually get numbers to be placed in these right spots to get a sum of A? Right? So let's try that out. I want a sum of 10. I really am worried about this 8 here. Okay? Now, wherever 8 goes, you need to have the other two numbers add up to 2. So either we're using 2 1s, which is impossible, or we've got to have 2 and a 0. Right? Now, does 8 have to actually go here? Well, no, 8 could go here. Things like that. Okay? And what we might be served by doing is figuring out the number of ways we can use these numbers to make 10. You know, with 7, I need 3 left over. I could have 3 and 0, or I could have 2 and 1. Those are ways to make 10 involving 7. 6, what could I do with 6? Well, I need 4. So you could have 3 and 1, or you could have 4 and 0. You can't use 2 and 2. Okay? How about 5? Well, we could have 4 and 1. Or maybe we could have 3 and 2. I can't use 5 and 0. So there's only a couple of these that have repeat numbers, right? So that's something to certainly try and focus on. 8 has to go somewhere, but 8 definitely couldn't go here because there's no way to get two sums involving 8. So let's just put 8 out here. And notice 2 is used a lot, 0 is used a lot, so let's try and put 2 and 0 here. Now, where could 7 go? Well, 7 would have to go either with 2 and 1, except 2 is sort of tied up at the moment. 7 could go with 3 and 0, so maybe we put 7 here and 3 here. Okay. Now, what about 6? Where could 6 go? Well, you could make 6 with 4 and a 0, except we've already used our 0. So I suppose we could make 6 using 3 and 1. 6 here and a 1 here. And now what's left over? 5 and 4, and they can just go here. Okay? But the 3 is sort of forced upon us up here. 8's got to go somewhere. Now, let's try and put the 3 somewhere else. Okay? What if we had 8 here? Right? Just exploring the question a bit more. You could put 2 here and 0 here. And then where could 7 go? Maybe 7 goes here and 1. And then 6, well, you could have 4 here, and then you'd have to have 5 and 1. Oops. So, okay, maybe that just doesn't work. Maybe because 10 is definitely the smallest sum we could get. Maybe 2 goes up here and 0 goes down here. You could try 7 and 1 here, and maybe 5 and 4. And then you could have 3 and 6. Uh-oh, that doesn't work. And we could play around with it. We might even be able to investigate a more mathematical way to realize that you really can't do anything else. You can exhaust your cases as much as you want. You'll find that 3 has to go in the middle here. So now the way we're doing that, that's really x plus 3, which I guess is really 2012, our smallest number, plus 3. And so 2012 would be here, 2014 would be here. We didn't actually need the 2012s. That's why we dropped them, to make calculation a little easier for us. Okay, so 2015 should be the answer, and that's going to be D. Okay, the value of U has to be 2015. Okay, so there we go. Question number 24, all squared away. We've got one more to go, so feel free to join me for question 25 in the following video.